let's transition this over. And we'll move some things around as we talk about what's what. So this is a shot of almost, I'm going to keep it zoomed in. I'd rather you see what I'm pointing at than the whole board. This is Rev 2 of the microcontroller trainer. What it does is allows me to prototype things very rapidly. Let me walk you through what I was thinking. Yeah, the board really isn't in focus. I'm going to make some adjustments, and we're going to improve on that a little bit. We are limited a little with some of the camera gear that we have right now, but I'll see what I can do about that. What the board really does is it lets you take any one of 4 different types of microcontrollers or computers, depending on what we're talking about. We'll get into that in a second, and build a project. Arduino, absolutely, this product works with the Arduino ecosystem. I've used the Arduino Nano microcontroller in tons of projects. I love the thing. I probably have 20 of them up in the drawer. It's my go-to Arduino. It fits on the board. The ESP32, that's a microcontroller that also works within the Arduino ecosystem if you want it to, and it has a combination of Wi-Fi and Bluetooth. Now, I think that's super cool. It gives me a lot of capabilities in communicating with things. Let me change the screen up here just a little bit more. I'm going to give you one more thing. And yeah, I don't love how that thing looks. That's not the greatest, but you're going to have to deal with a little fuzzy. That's what the camera can do at the moment. I'll go one more here. Add one more video source. And make this small. All right, so we're going to go with this. So, Trainer Rev 2. It all starts with the breadboard. The breadboard right here, this is the center of the universe. The breadboard is built, oh, that's nice. I just took a USB device off and increased my latency. I think I was just saturating the bus. Anyway, the breadboard in this is a bus board prototyping systems breadboard. If you've bought a breadboard on eBay, you probably got really mad really quick. I mean, right here, this is an eBay breadboard. It's probably got a name that I can't pronounce, and it's garbage. You prototype a circuit, you plug things in and out of it, you get high resistance, you get bad connections, it's unreliable. Cheap breadboards are cheap for a reason. They're junk. This breadboard costs me like $8. It's a significant portion of the cost of the kit. I won't even for a second consider any other breadboard for this kit. It's not worth it. I want me and you guys to have the best prototyping experience you can, and a quality breadboard is part of it. The breadboard has a power rail at the top and at the bottom. The power rail is connected from left to right all the way across. Some of the other breadboards you may run into are split in the middle. I didn't want that for this design. It was important to me to have the rail go all the way through. The board itself has a built-in power supply. I have 2 LM317s down here in the bottom left-hand corner, linear regulators that are good for really, without pushing the thing, a half an amp. You could get more, but what I had in mind as a design factor was half an amp of power for the 5-volt rail, half an amp of power for the 3.3-volt rail. I break that power out at a header right here just south of the board. I give you ground, 3.3, and 5 volts. My intention was that you could extend 5 volts to one of these rails on the breadboard and 3.3 to the other, and then power anything else on the board. Nothing else on this board has power until you give it power. If you're going to use the Arduino Nano, you put a jumper in and you give it power. You choose, am I going to power it at 3.3 or 5 volts? Some things that don't have a choice, but many of the things on the board do. So we've given you that ability. If you're only using the TFT and the ESP32, then only power those devices. Now that brings me to the next topic, power load. I've not load tested the board. I don't know exactly how much the current draw is with every combination of every element. That is something I will know for Rev 3. It's a design thing that I'm doing, is I'm going to map that all out. I do know that if you're wanting to back power the board, and that's why I bring this up now, because there's another option, two other options for powering your projects. One of them is back powering the board through the microcontroller you're using. So when you take that microcontroller and plug it into that 5-volt rail or that 3.3-volt rail, power's going the other direction too. So if I have a 5-volt microcontroller, I'm plugging that ESP32 into USB, and I pull 5 volts off that ESP32 and I bring it to the rail and I connect it to that header on the board. I'm back powering the 5-volt logic on the board. So it can go either direction. It's completely flexible. What I was getting at, and a reason you might consider different ways of powering things, is if I'm trying to use that ESP32 and I've got the radio on, I'm drawing some current there, and I want to use that TFT screen, I'm actually getting to the threshold of where things may not be stable. I need additional power. So powering the TFT directly off the ESP32, not such a great idea. That's where getting power from the board can help. Or if you have a project that exceeds the power ratings even of my built-in power supply on the board, that's okay too. Use your bench supply and backfeed the breadboard or backfeed the trainer board. It's completely flexible. Knowing that, so I talked about power. Let's talk about ground. Everything on this board has the ground already connected. It's one big ground plane, and that's just less jumper wiring that you have to do. I've made some design decisions, things like the push-button switches. I've tied one leg of the push-button switch to ground. Depending how you're going to use it on your microcontroller, you may need a pull-up resistor on the breadboard, or you may be using the internal pull-up of your Arduino or your ESP32, and it'll interface just directly with these buttons. We've considered that for you and given you some flexibility. Rotary encoders. There's more than one way to wire and use a rotary encoder. There are different libraries out there and different approaches. Some people want to do hardware debounce. It's this huge conversation I'm not going to get into right now. But I've left it flexible. I didn't design you into a corner where you had to do things my way. Let's talk a little bit about each component on the trainer, why I chose it, and how it works. So we've already talked about the power supply down here in the left-hand corner. Using that power supply is completely optional. If you don't want to use it and you want to back power the board some other way, go for it. Half the time I'm using the board, I'm not using the power supply. However, in Rev 3, we're going to have an on-board LiPo, so it makes the thing portable. More about that when we get into Rev 3 stuff. So the next thing we've got on the board, and I'm gonna switch the board over here, show you another one, because I stole the port off the other one. Arduino Nano V3. They come in a few different varieties. You get what I can order at the time of building the thing, but most of them have a mini USB connector. I'm a big fan of the mini USB connector. I think it's more durable than the micro. Just personal experience. But I break out all the pins on the Arduino to a header connector. We already talked about the power header. Well, over here, these are all Arduino Nano pins. So if you were going to use that Arduino Nano on a breadboard, you could just plug it right here into the breadboard if you wanted to and prototype with it, but I've made it easier. I've broken out the pins so that you can jumper what you need to the breadboard. You don't have to take up the space on the breadboard. I've done that for you here in the trainer. Moving on. We have 4 push-button switches. The 4 push-button switches, like I already mentioned, have one leg wired to ground. These are momentary push buttons. That's a really handy combination for when you want to use it as an interrupt or an input, an input device on the Arduino. I can push the button. It pulls that pin down to ground. I can configure the pin as a integrated pull-up. And those push buttons, a couple of lines of code, and these things are working. I generally do my debouncing in software. If you're not familiar with debouncing, go Google switch debouncing and learn a little bit about how a micro switch works on the inside and why bounce can be a problem. But again, I left it flexible. I broke this out to hardware pins. So if you want to throw some capacitors on it, and implement a hardware debounce routine, you can do that. Or if you're just experimenting, use software debouncing. So that talks about the switches. Right above the switches, we have 4 serially controlled LEDs. I'm told by some that these are referred to as neopixels, but I've also heard people call them smart LEDs. These serially controlled LEDs are configured in a strand. So the data comes out of your microcontroller, hits the first LED, passes through it, hits the second, passes through it, hits the third or the fourth, and then passes back to the header connector. I've got a data in pin and a data out pin. That'll allow you to connect this string or strip of LEDs in any way you want. You can connect it before some other offboard strip or after some other offboard strip. It's however you want to do it. I've got a resistor R1 right here on the board to protect the data line from an overcurrent that can kill the first LED. And I've got a large filter capacitor to help keep the power clean that's powering that strip. As we move to the right, this is the second microcontroller on the board. I've already talked about this Arduino Nano. This is an ESP8266. Specifically, it's an ESP01. The ESP01 originally kind of hit the maker, market, if you want to call it that, community, as a AT command-based controllable Wi-Fi module. So it's got a serial port on one side, and it's got Wi-Fi on the other. So you would connect it to your Arduino to wireless enable your Arduino. Well, not too far later on, people discovered, hey, I can run Arduino code on this thing natively. It gives me 2 GPIO lines. That's a whole lot of capability for just such a tiny little chip or a tiny little board. In fact, let me show you what it can do. I've got an ESP01 on this trainer board right here. Let me get it in frame a little better. I've got an ESP01 on this trainer board right here. And this is wired up to a 0.96-inch OLED. That's an organic LED display. I love the way an OLED looks. You get outside, you can see it. It's a lot more brilliant than trying to look at an LCD screen. Well, I've got this thing mocked up essentially as an OLED tester. The code that I've got on this is going to, from that ESP01, which remember I said it's wireless, it's going to connect, it's going to fire up, connect to my Wi-Fi network, and display data on the screen. So not only, I'm doing one of two things here. Not only am I proving wireless works, I'm making a wireless connection on the ESP01. You can see the little red light on it down here. I'm also using an OLED. Now that OLED is what we call I2C controlled. It has 2 wires, a clock pin and a data pin. And between the clock and the data pin, we connect them to the microcontroller. I've used it on all of these. The ESP01 can do it. The ESP32, which we'll talk about in a minute, can do it. And the Arduino Nano can do it. All these devices can talk I2C. And the cool thing about I2C is it's an addressable bus. So you can put, I think it's like 128 devices. Don't quote me on that number, but you can put a lot of devices on an I2C bus and talk to them by addressing them. You send out your commands to a destination address. I'm sending commands to something addressed where this OLED is. And it's very easy to talk to. But this right here, this is what the trainer board was built to do. It was built to let me very quickly mock this up. It took me like 10 minutes to build this. Now, the first time I built it, it didn't work. I found out I had some flaky jumper wires, so I threw them in the trash can. But the second time I built it, it was like 5 or 10 minutes, and this thing was working, including code. You do that with an Arduino Uno. It's just, this makes things so much faster. We've got, let's see, so I've talked about the rotary encoders over here on the right, bottom right. Rotary encoders are cool. They spin 360 degrees and never stop. You got up to like the radio in your car stereo and you turn it to tune a channel or something. That is a rotary encoder. It looks like a potentiometer, but it's not. There's no resistance changing here. This is actually, on the inside, it's two switches that are wired, two signal lines wired 100 degrees. It's either 90 degrees or 180 degrees. I think it's 180 degrees out of phase with each other. So you're going to have these rising and falling signals that occur on those two encoder lines, those signal lines, as I turn this. Well, in software, I can look at that and I can decide how many detents did it turn. You know, every little click you feel when you turn it, that's called a detent. How many detents forward did it go? Although I don't necessarily really care so much on a rotary encoder, because I'm usually looking at a display that the rotary encoder is causing to change. So bouncing, debouncing of a switch like you do on a push button, it's still a thing with encoders, but it's not as big of a deal. But so we've got two of those rotary encoders. So when you're building user interfaces, you're changing the display on that screen. The encoders can do it. So that it's what I consider a fundamental building block of a user interface. Oh, and these things also have a switch in them. You can push it. There's a push button. So just like you have 4 push buttons over here, each one of these rotary encoders also has a push button. So you've got a total of 6 push button switches on this trainer and 2 rotary encoders. That's a whole lot of things for developing user interfaces. Now, as I move around the board up to the right, this is an HC05. In fact, it's in a socket, and there are a handful of different modules that can fit in that socket. There's a newer one called, I think it's an AT09, but the HC05 was a Bluetooth, I think Bluetooth 2.0 serial interface. So you remember how I said this ESP01 was originally a way to add Wi-Fi to an Arduino? Well, that's how people used this HC05. It let them Bluetooth enable their Arduino. There are ways to wire that HC05 up to wirelessly over Bluetooth program your Arduino. Or your Arduino can communicate with other Bluetooth devices. Pretty cool. That AT09, that newer module that I talked about, is pin compatible and will also plug in the same circuit, or plug in the same socket. And it's BLE, Bluetooth Low Energy, also known as Bluetooth 4.0. So the board will support both. If you want to add Bluetooth to your Arduino Nano, there you go. We've got this TFT screen, and I originally designed the board so that either the 2.4-inch screen, which is what you see installed on it, or a smaller 2.2-inch screen that I happen to have on hand could plug in and be used. Larger screens have come out, including a 2.8-inch display. This might be, nope, that's a 2.4. I'm actually going to support all of them on the Rev 3 board. You can plug a 2.8-inch into this. The pins on the right-hand side, which are used for the SD card reader, there's actually an SD card slot in the back of this thing. They won't line up, so you have to run some jumper wires. But James, Bald Engineer, when I sent his kit, I accidentally screwed up and I ordered a 2.8-inch screen and sent it with his kit. I had no idea 2.8-inch screens existed. It was just a screw up when I ordered parts. You know, he opens the thing up and it's like Christmas. Hey, my screen's bigger than everybody else's. Pretty cool. You had to run some jumpers. But the next version of the board, the Rev 3, is built with pinouts for all 3 board sizes. So what's cool about this screen? Well, it's a touch screen. It's resistive touch. So not only is it a display, a TFT display, it looks like a little LCD screen like on your iPhone, but it's also resistive touch capable. So you can use your finger, or you can use those little pens like a Nintendo DS would have, you know, those little pens your kids are using. You can use that and build your own user interface. So maybe you don't need push buttons or rotary encoders. You can build your entire user interface just out of touch. This device is communicated with using something called SPI, the Serial Peripheral Interface. I think is what that's called. SPI is not a bus like I2C. People like to compare them, but they're very different. SPI actually has what's called a chip select or a device select signal that you trigger a pin to let the device know you're trying to communicate with it. So it takes more wires than I2C, but it's just a different approach. But what's cool is the same data and the same clock pins from my microcontroller can drive the touch interface, the screen, and the SD card slot. So I'm not using very many pins on this thing. I've got a couple of other pins used for supporting capabilities, but it's a pretty efficient UI. That leaves me, there's two more things I want to show you on the board. There's the ESP32. Right now, this is one of my favorite microcontrollers. It can work in the Arduino ecosystem. It's got Bluetooth and wireless built in. It's 2.4 gigahertz only, if I recall. But that's a really feature-packed piece of hardware that only costs a few dollars. My go-to microcontroller is the ESP32 right now. I don't know what more to say about it. It's just that awesome. You can use so many different pins as interrupt pins. It's just got so few limitations. I mean, it's got plenty of limitations, you know. Everything does. But it's so flexible that it's amazing for me as an experimenter. There's one more thing on the board that I want to talk about, and that's the Raspberry Pi. And I don't have one installed here in a moment, but there's a header on this board where a Pi Zero can install. Let me grab one real quick and show you guys exactly what that application looks like. I don't do tons with the Raspberry Pi. That's if I can find a Pi. I don't do tons with the Pi. It's not my platform of choice. But from time to time, I do want to develop something and use a Pi as part of a project. The most popular Pi out there, I think because it's so cheap, is this little guy. It's called the Pi Zero W. It's wireless, and I think it's Bluetooth as well. And you can get it with this header pre-installed. Well, that header can plug right in to the trainer board, just like that. And now I've broken out all the pins on the Raspberry Pi. So if you want to use a Raspberry Pi, which is a Linux-based computer, to experiment with electronics, you can do it equally well as an ESP32 or an Arduino Nano or an ESP8266. The choice is yours. I'm covering 4 major ecosystems here on one board, and that was the intent. I wanted to allow for flexibility in the product so that you don't have to think about what are my limitations. You think about what are my capabilities, what are my features, what can I do, not what can this thing not let me do. That's Rev 2.0, guys. That information is enough to get you started experimenting with the microcontroller trainer.